ourselves up. We're running. All right, so site light. So site light, guys, a couple of things that we're going to do about site light. I know you use the visual. Aaron, my friend, we use visual. You guys, I know for sure you know how to build the box, which is the building. You do perimeter lights around the building, right? And I also know how to do parking lot lights with parking lot lights. And that's what basically this chapter is talking about. A few things that we need to highlight. This is my favorite consideration in lamp selection for site light. We decided to use LEDs. LEDs are the future right now. But here's where basically, if you don't use LEDs, metal halide or high pressure sodium are your two choices when it comes to the site. That's it, for the most part. So consideration for the lamp, the type of the lamp they're going to use. Illuminance values, which is the foot candle that we need. I think in our project we use 0.5 as a minimum. An average, what is it? I can't remember what the average is that we use. The minimum to average to minimum, what was that minimum? 4 to 1. 4 to 1. So that's what we're going to talk about, guys. Calculate the power limit. This is ComCheck. We use ComCheck, and ComCheck gave us a certain value that you shall not exceed if you are to meet the energy code. That also talks about it. And power demand for the site light, how much power demand you need to circuit them. Locate luminaires on the site. How do you locate them? With the control lines that we have. Control options. What type of options do you need when it comes to controlling the light? A snap switch or magnetic starters, controlled by a timer or a bunch of other things. So that's what we're going to be, this chapter guys talk about. Lamp selection. So 3 factors should be considered when you do lamp selection. And this is, I know we use LEDs, right? In our project, we decided to use everything LEDs. A couple of things we have to do. The amount of power the lamp requires to provide, the power. So that's number 1, is watt. The watts of the fixture. How efficient the watts provided the needed light. The watts, the lumens, they call them lumen per watt. The efficiency of your fixture, or the efficacy of your fixture. That's a big deal. That's why we picked LEDs there, because they're very efficient. They give you a lot of light for a little amount of power. So they're efficient, energy efficient, and so forth. Color, number 2, color. Do you care about distinguishing between green and black in the parking lot or not? Color rendering as well as color discrimination, which would be, is this an issue? Typically in a parking lot, guys, it's not an issue. As long as you can see your car, it's not really a big deal, especially with those buzzers right now, is to sit there and distinguish the green from the blue, dark blue from dark green. And the last one, and this is probably Jeff and Darren, you guys adhere to it a lot, maintenance. When you put lights, guys, in the parking lot, you need a means of reaching into it to change it and clean it and do all this stuff, right? So maintaining the fixture is a big deal. Is it high maintenance fixture that's going to cost you a lot of, over the last, say 5 years or so, before you lamp them, it's going to cost you a lot of money to maintain it, or is it a low maintenance fixture? So that's a big deal, guys. 3 factors to consider when you're selecting a lamp and a fixture. Any comments, guys? Any questions? Common sense, right? Common sense, not a whole lot. Power control. The second thing that we'll talk about, guys, is on this particular one is power control. Power control can be as simple as a snap switch, but I don't know of anyone who uses a snap switch to control your lights. Large number of lights may need something called contactor, and that contactor, guys, lighting contactors, you hear them all the time. It looks something like this, and it has multiple lights connected to multiple lights, and the voltage, say 277 on each leg, and each one of these are tied to a neutral, of course. Here's my neutral, phase A, phase B, phase C. These will close, and I have, let's just say, a couple of 10 lights here, and I have 10 lights and 10 lights. All of them are fed from 20 amp circuit, 20 amp, 20 amp, 20 amp. Can you guys see that? 20 amp circuit going to a contactor to turn 10 lights 30 lights basically in a parking lot through a contactor. How do you control this contactor is up to you. So when you do the control circuit, guys, will be somewhere here, and you have a clock, astronomical clock, right in here to control this contactor. That's how they do it in bigger parking lot. A contactor, slam that big contactor. This will be a 2 amp, a 20 amp contactor. You can have 30 amp contactor, 40 amp contactor, 50 amp contactors, and you put tons of lights in bigger parking lots. Any comments, guys, about this contactor way of controlling your lights? The way we did our lights, guys, in the parking lot, I told you to put them on a timer. The timer literally will have a 20 amp timer. It's a contactor. What is the timer? It times out and opens contacts. So less cheaper way than putting a big spiel magnetic contactor like lighting contactors. Any comments, guys, about the lighting contactors versus switches? Or may energizes a panel. Another method, I don't know if you go to a major parking lot, they might actually, this is really cool. They might have, see that panel here? Look at that panel there. They might open and close a contactor that control the whole panel. So they will have multiple lighting circuits going all over, and the whole panel is put on a magnetic starter. When they turn things on, the panel goes on and off, and that will control hundreds of lights. So, but the problem with the problem with this, some of these, like you're putting all your eggs in one basket. So if this magnetic starter is to fail, you have all the lights are off. So there's a drawback. A lot of people, my understanding, guys, is they use 30 amp and 40 amp, typically 30 amp magnetic starters, and they feed tons of lights. You don't want to do more than 30 because that's putting all your eggs in one basket. You know, if something is to happen, do you want all the lights at the mall market to go off? You mean at the same time? So that's kind of where typically 30 amp contactors are at the optimum. Okay, so that's your control system. Power control. We talked about manual, guys. The advantage of manual is it doesn't cost you a whole lot of money, but you have to trigger the switch. Automated, it costs you a little bit of money, and maintenance, and also has some maintenance costs, but it's reliable. It's reliable. So if you are in a parking lot 99% of the time, Jeff, if you're doing parking lot 99% of the time, you're doing some type of fully automated means of controlling these parking lots. Does that make sense, guys? You're not going to go there and turn a switch on for your parking lot. Typically, is this, especially in this day and age, either magnetic starters, a timer, or a magnetic starter that controls all your parking lot. So that's my control, and feel free to swing to do it. Now the lighting sources. There's 3 lighting sources. We started lighting intensively, guys, in the fall. Do you guys remember when we talked about details lights? There's incandescent light, source number 1, source number 2, fluorescent, source number 3, high intensity discharge. Drop this when it comes to parking lot lights and outside lights for the most part. And your option really is high intensity discharge lamps. And we didn't do a high intensity discharge lamp this time, guys. And the second, the fourth option that we did is what? LEDs. LEDs. The fourth option was LEDs. Why did we pick LEDs? Because they're more efficient. They're expensive, but they're more efficient and emerging, coming, controlling, dominating technology. That's probably will be taking over for indoor and outdoor lights. Any comments about these sources? Jeff? Makes sense? Quick review of things that we've done. Okay, this is a little bit, guys, how the incandescent lamp works, the Edison type lamps. There's a filament. This is the cheapest, the cheapest, easiest way of generating lamps is you have a filament resistor inside a glass bulb and vacuumed it. Not a whole lot of air, or you have inert gas inside it, and you put the current inside it, it heats up, glows. That's what the cheapest, easiest way. They're trying to get rid of that bulb, right now, because it's not efficient. That's the easiest, cheapest way, guys, of doing. So the filament is a coil wire, emit light, as it heats, it emits the light. And we studied lights in details in the fall, if you guys remember. Then they go the halogen type. They make it more efficient. It lasts. It light the light. It lives longer. Gives more light by adding halogen into that bulb. Tungsten filament, a special tungsten filament, and some type of gases inside it. They make it very bright and lives longer. So this is, think of this one as a kind of a high, the same thing like incandescent, except it's on steroids, making it better. Still not a good option for general lighting. And again, so moving, the third option is fluorescent lights. Fluorescent lights, guys, we all know that you have it's tubular lamp with filaments at each end. At each end, so they have these little filament resistors at each end, like a resistor. You heat them up and they start bombarding each other with electrons by starting an arc. So electrons bombarding the phosphorus area. So they created, and I'm not going to go through the whole thing, guys. They created an arc. As the arc go from anode to cathode or so, that arc is, I believe, if you remember right, it's ultraviolet light, and the phosphorus will convert it into visible light. You guys remember that, what we did in the fall? So that's the way it works. Color, you can get them in any color based on the phosphorus that you use. So you can get them green. What's their advantages? They live longer, especially indoor. Look at them right above your head. And fair tolerance for voltage swinging. So they're good with voltage swinging. They can give you for voltage drop conservation, they're better. Any comments, guys, about fluorescent? Anybody have seen fluorescent outside in a parking lot in Minnesota? Maybe in other states. Our problem here in Minnesota of fluorescent is cold. Yeah, they don't start. They're not good at cold weather. Maybe in other states where it's not as cold, there will be one option to use a fluorescent. But it could be an option. There are fluorescent lights meant to be for parking lot. So, but it's not really commonly used, at least here. High intensity discharge. This is your fixture, your lamp of choice, guys, when it comes to a parking lot and outdoor. Mercury. We got sick of having three-legged frogs. You know why we got rid of mercury? You remember playing with a mercury like this? Like my wife always say, well, the frogs are having 3 legs or 5 legs instead of 4 legs. So we got sick of making three-legged frogs. And we want to save Mother Nature, rightfully so. So we got rid of the mercury, right? Everybody understand the whole mercury business right now? All this diminished, nobody uses it. Here's the second option for you. And the second option, guys, is metal halide. So these are all high intensity discharge. They create an arc, and they treated the arc by some type of a gas they put inside the bulb. That gas or material could be liquid, could be metal halide or metal halide or mercury. So they treated the arc. Okay, metal halide. This is typically, unless you use LED, that's one of the options that you would use in a parking lot. The second option is, guys, high pressure sodium. Again, they put high pressure sodium inside the bulb. They treat it. What's the problem with high pressure sodium, though? So your option number one, really, as for the most part, is metal halide. High pressure sodium, they're great, more efficient. Anybody knows what the problem with them? Color discrimination. The color discrimination is poor color discrimination. Low pressure sodium is option number 3, and my understanding this would be probably for interstates and highways, guys, because if you're driving at 65 miles an hour, do you care to know the car next to you is green, dark green, or really blue? You care about seeing it. So color discrimination or color rendering is not an issue when you're driving that fast, unless you're a police, you want to identify the car. That's your problem then. So that's why color discrimination is void, not existence. But it will tell you that there is an object moving and you can see the object, but you can't tell what the color is, and who cares if you're running, like I said, 85 miles an hour. Any comments, guys, about these options? So your options basically are limited to, unless you use LEDs. We used LEDs, remember? We did use LEDs. Your options are really limited to metal halide or treated high pressure sodium for outside lights. We used to, for years, Joe, when we did the projects, guys, we used to use metal halide and high pressure sodium outside. This year and last year were the first 2 years. As a matter of fact, did we do the commercial project LEDs? No, we did them, yeah. The first 2 years that we used LEDs in the industrial project, this year and last year. Our option was always metal halide, high pressure sodium. Okay, so that's your option. Here's a couple of comparing the three options, guys. When you compare lights together, watt rating is important, how high the watts for the fixture can get. Lumen rating, how much lumens lights that can get. Total watts, lamp. This is the most important things too. Very, very important when it comes to conservation. Lamp life, the longer it lives, the less maintenance you have to deal with. Lamp length is not an issue. Lamp load, the load in that lamp. This is just calculating how many loads on each one of these lamps that they have. Okay, so that's a couple of things consideration to have to look when comparing. Again, we're not gonna we said we are right in here when it comes to parking lot lights, and we're talking about site lights. We're in these areas. Okay, then we move from lamps, guys, into lamp distribution. Lamp distribution affected by three factors: lamp, reflectors, and lenses. Now we're talking about what type of lamp do you use: high intensity discharge, halogen, whatever. Number two, the reflectors they're going to be using for it to reflect the light directly. Do you guys remember we have diffusers and reflectors from from one that gives you 380 degrees, 360 degrees into ones that give you only 80 degrees. It shoots it right in the front. So there's so many ways of directing the light. And the lenses they will use that could absorb some of your lights, clear glasses or plastic designed to redirect the light, the lenses. So these are what makes your luminaire, your fixture, your lighting fixture. And we talked intensively, guys, about lighting fixture. When you have lights out of a lighting fixture, lamp is only one factor. The reflectors is another factor. The lenses, the louvers is a third factor. A guard to guard that fixture is a couple of factors. All these will affect how much lumens you can get out of this fixture at that particular location. Any comments, my friends? Any questions? It's not Monday, guys. It's Tuesday today. So, and I know we went through that one a little bit intensively. Lamp efficacy. Efficacy is efficiency with different unit numbers. Dividing, so you take the lumens and you divide it by the watts. That's how you get the efficacy of the fixture. The higher the number, the better the fixture. That's how you become environmentally friendly, save energy, save Mother Earth, by using high efficacy lamps. Okay, that's why we decided to use what, James? We decided to use LEDs, right? Because it has the highest efficacy as of now. Okay, so that's basically when you are using a ballast or a driver, you have to take the watts consumed by the ballast into consideration. For example, if you have a fluorescent light, guys, and your lamps, your lamp it has three lamps. Each one of them has let's just say 32 watt. Is this all the watts that this lamp is going to take? No. What else you need to add to it? You need to add the watts or the ballast, right? So that's what's right. The ballast have electronics in it, electronic ballast or electromagnetic ballast have to have losses in them. So typically you add another 10%, 5 to 10%, guys, on this number to what? To accommodate for electronic and or electromagnetic ballast. Have you guys when we did visual? Have you anyone of you have tried when you multiply? We use LEDs though. Even with fluorescent, when you multiply the number of lamps by the watts of each lamps, and you look what visual is giving you, typically it's what visual gives you more than this. Anybody wondered why? That's because of the losses in the ballast, or if it's LEDs, we have a driver, right? We have a driver that drives the LED light. What's the driver? The driver is 120 volt here. You have 24 volt DC. So that electronic device here that convert the converter AC to DC wants to eat a little bit of power. So that's where the losses happen to be. So typically if you add the watts at 10% on the watts for losses, you're very close. Okay, so that's my color characteristics, guys. So we have provide color of an object. So perceived color of an object affected by the color of the object itself and the color of the height used. So if the color is an issue, what we call it color discrimination, you have to use a fixture that can give you at least in a parking lot minimum color discrimination. You don't want a fixture that makes all the lights look alike, all the cars look alike. So that's why, guys, it used to be your fixture of choice is metal halide and high pressure sodium, because they give you minimum amount of color discrimination where you can see and distinguish between your cars, but they're not really the best in when it comes to color discrimination. Um, so that's the most important thing about the colors when it comes to the colors. Here's a description of color discrimination or color characteristics. The best when it comes to distinguishing between the colors to see the true color of the objects is basically incandescent rocks. But what's the problem with that? It's expensive. And then we have accepted by many as a color standard, considered warm light. Blue will appear somewhat gray. This is disadvantage. Look at the metal halide, mercury. Let's go directly into fluorescent here. Wide variety makes any degree of color rendering, so it's you can treat it to get you. So if you get metal halide, that's our option. Metal halide like mercury, so has a cool greenish light, red and oranges will appear somewhat gray. That's kind of a disadvantage. If you have a red and oranges appears gray, and there's so many treatment they treat them, guys. So it's really, some of this might not even apply, but it's still a good color rendering though. Look at low pressure sodium though. It's an orange yellow light, permits good color discrimination except with some reds and blues. High pressure sodium, I think these are switched. Permit no color discrimination. These are switched, right? Can you guys do that? I believe these are switched. The description is switched because low pressure sodium is the one yellow and black and white, basically permits no color discrimination except. Can you guys switch that one? These two are switched. So low pressure sodium, great fixture except no color discrimination. You can't see which color is your equipment is. Any comment, guys? Any questions about these fixtures? Comment, questions? Okay, lamp maintenance. So often lamp can be expected to fail. So lamp maintenance, guys, there's a lot of factors that affect it. We talked about difficult in replacing them. So the most important thing when you put a lamp in any location is ask, is it difficult to replace that lamp? Do I need a crane to go pick me up on that 200 feet lamp fixture in the parking lot or no? I was at the seminar, guys, when we gave you the day off, and they were talking about wind turbines. The disadvantage of the wind turbines, when they put that wind right at the top of a 200 or 200 foot tower, have anybody wonder how are they going to bring that tower? If something happened to the engine, how are they going to bring it down? The drawback of it, the minute that you put it there, you have all these cranes set up there and you put them. But if something happened to that generator engine, to the generator at the top, bringing it down, they were saying just to bring the crane, $100,000 to bring the crane and mount that crane right next to it, $100,000. So imagine the maintenance, the amount of maintenance and money you have to do. So when you put your fixture, keep this into consideration. So when it comes to living longer, of course, incandescent is the worst. So most of the fluorescent guys and high intensity discharge lived 18,000 hours or longer. I think incandescent, what is it, 2,000? What did we say, 2,000 or 4,000 hours? 1,000 or 1,000, yeah. So that's why fluorescent and high intensity discharge becoming the option when it comes to maintenance. They don't fail often. They live longer. Illuminance selection, amount of light needed for exterior lights depend upon the type of the activities. When we did the parking lot, guys, we said we did two types of lights, one for the general parking lot lights and one for the facade of the building. Sometimes they do sidewalks, guys. We did not do a whole lot of calculation for sidewalks. Actually, our perimeter of the building was part of it is the sidewalk. And these activities, so what type of lights depends on what type of activity you're going to do. Are you doing a parking lot for people to park in? Are you doing the sidewalks? Are you doing facade of the building? And we did the facade and the parking lot. IES is the book when it comes to recommendation of how much lumens or foot candles you need for every area. And the software that we use, guys, is Visual. when you pull this information based on the parking lot, it defaults you to a certain foot candle um, that accepted by IES standards. And we dealt with this one when it comes to um, here's a couple of recommendations, and these could change from one to another. For example, I believe these are the minimum. For your parking lot, here's your minimum. For roadway, here's your, we didn't do roadway. Storage area 20, we're not in the storage. Pedestrian, 0.9. Remember, these are very, compared to right on the top of your head, Aaron, right now is we're looking probably at what, 60-foot candle. Compare this one to 0.9 in a pedestrian. So you don't sit right there and read a newspaper, right? What do? You go there and when you do this is just for you to be able to find your way through to your destination. Okay. This is we used ASHRAE, guys. This is the energy code ComCheck that I use with Chad. ASHRAE, the one that we use is ASHRAE 2010 for our project. We were lucky because we have LEDs, so we can meet. We have LEDs. We have multiple levels of switching for the auto switching occupancy sensors. And with ASHRAE, if you have LEDs and you have an auto means of controlling your lights, you almost always meet the code. Okay, but this is just recommendation from ASHRAE, guys, for parking lot. Here's the density that we have. I can't recall what we did when we did the parking lot. You guys did it 30 watt per space. Space is a parking slot. I think we did it per square foot. If you guys remember ASHRAE, I can't remember what was it. The watt per square foot that they gave us. I can't remember what the watt per square foot. Roads, here's what they give you: 2 watt per feet, linear feet. Storage area, as well as pedestrian. I can't emphasize, these are your energy code. These are your energy code consideration. Okay, the rest of it, guys, is when you put isofoot candle curves. Remember the isofoot candle curves? When you put a picture like this, these lines represent the foot candle in this area. So, for example, every point, and I'm telling you something that you guys know, all these points are represented by 2.8. All these points are represented by what? On this curve, represented by 1.1 all the way into 11. Am I reading it right here? No, 0.11. Okay, this is a point. So all these, the further away you go from the fixture, you can see the further away you go from the fixture, the less light you're going to get, right? So that's your isofoot candle curves that when you guys dropped it in visual, remember that? You drop, and we cut it up at 0.5. Here they're cutting at 0.11. That's the curve that they're cutting. This is their limit. Ours was a 0.5. I want to cut at 0.5. Okay, we got that one. Then when you have a parking lot, then my friend, does that look familiar? You put all your parking lot, you put all the cutoff. They're cutting. Here's is 1.1. So this area will be lit from 2 fixtures. You allow them to overlap. Remember how we did visual? A little bit of overlap in each area. That's typically how we do it. And then we calculate what the average or the minimum in the area based on the consideration that we have. Any comments, any questions, guys, about dropping your fixtures and having the foot candle curves, nice foot candle curves laid out to cover the area that you need? This area, I believe the cutoff, you don't want to go less than 0.5 and all these parameters. Can you guys see that? All around the building, that's your minimum basically for all these fixtures. Any comments, any questions, guys? Any comments, any questions? Comments, questions? So that's basically what we do here. Then pedestrian lights, guys. Here's a couple of recommendations. If this is a sidewalk, typically you put your light here with PVC conduit, 56 inches, and it will throw some light up to, I don't know, probably 3 feet. Up to 3 feet, this will throw light for your pedestrian. That's one way of doing a pedestrian light. We didn't do that one. A couple of consideration, guys, in different locations where you can do pedestrian lights or walk illumination. So here's one option, up to 36, and here's another option, 24. If you're in Minnesota, typically, what do you pay attention here? The snow, right? So if you put your lights in one location, typically when they're a little bit high, I think at least 2 feet or higher, to get you enough light. Okay, now we go into the installation. When you install the system, when you guys did the parking lot, there are two options. Option one is conduit and wire, PVC conduits, and you put wires inside it, expensive. Option number two, you use a UF cable, underground buried directly buried cable. But this is the key point. Every time you go under a sidewalk, you have to do what? Race with. Why? Because you don't want to tear the sidewalk to maintain this cable. Everybody understand? UF cable is your wiring of choice, cheapest. But then you have to put conduits under every sidewalk, or like we did in our project when you guys designed, we put what, 3/4 of an inch or half an inch? No, 3/4 of an inch or an inch conduit, 1 inch conduit between all the fixtures, and we'll pull the wire. So two options. Why cable? Cable is cheaper. Important consideration when we do, guys, circuit arrangement and conductor size. And typically we say that a parking lot, you don't want to pull less than number 8. Less than number 8, guys, in a parking lot, you will be full to pull less than number 8. Smaller parking lot. There are parking lot where they pull, guys, 2/0 as a feeder going from one fixture to fixture to fixture, and they tab that 1/0 and feed multiple fixtures. Anybody knows why when it comes to the parking lot we have to have a bigger conductor? Voltage drop. So don't be surprised if when you look at the blueprints that you see a 1/0, 2/0 for the parking lot, even though it's landing on a 30 amp circuit or a 20 amp circuit, because of voltage drop. The way they do it, guys, is they pull the feeder here. Here's my see a 1/0, and then they tap it from here going to the lighting fixture. Here's my lighting fixture here, and right in here they fuse them. Here's my 20 amp fuse. You see how they control them? So this becomes, this conductor is number 12, and this conductor here is number 1/0. And they keep going from fixture to fixture to fixture. Does that make sense? So you have inline fuse, they call it inline fuse. By doing it this way, they get a good voltage drop, low voltage drop, and also they still maintain protecting the number 12 conductor inside the pole. You don't want to put 4/0 all the way to the fixture. Any comments, guys? Any questions? So what's the issue? Voltage drop is a major consideration. Select control of the lighting. Selection of control, we talked about two types of control, guys, either timers or magnetic contactors, which is some form of a timer, controlled by a clock, astronomical clock, or a timer. Astronomical clock or a timer. And then you can interface it with your security system, your heating and cooling system, building automation system. All these guys are completely interfaced. Any comments, any questions, my friends? Joe? No? Okay, so that's basically it. Lighting control, like we said, when you have your 1, 2, 3, and I'm doing 3-phase here, guys. Here's my 3-phase, 3-phase, 3-phase. These are 20 amp going to multiple sets of lights, and I'm using here's one set, one set, one set, and from this side you take the neutral, right? It's phase A, phase B, phase C. That's typically how you wire a lot of them. And I'm going to have 10 here, 10 here, 10 here, and these are big lights. So 10 in each, or it could be 5 in each if they're 20 amps. And these wires here, I'm going to make them number 6 conductor. Everybody knows why number 6 conductors? Because they're going a longer distances. Okay, so now controlling this contactor here, here's what this comes. When you control this contactor, your option number 1 for controlling this guy is photo cell control. Your option number 2 is a clock. Option number 3, dimmer, and not really a whole option. Override switches, you can have also an override for the auto. So if you turn them on at a different time. So you really photo cell control or time clock, astronomical clock is another option to control this magnetic contactors. Or you can have just a contactor, guys. This is the big spiel, 3-phase. You can make just a single phase, one of them. One phase on a timer, landing on a timer that controls that particular phase. Any comments, any questions? Any comments, any questions? What you're looking at right here, this boy is called magnetic contactor, or contactors, lighting contactors. They call them lighting contactors. Exactly like the one, please, a little i.e. these contactors there, except they're NEMA, typically NEMA and big. Any comments, guys? Any questions about controlling them? So that's your control. And this is all I have for you guys. So summary, color renditions or color discrimination, maintenance, illumination, and luminaire are the major parts when it comes to site or parking lot. Any comments, any questions? I know some of this we covered, guys. It's a simple chapter. After this one, you're not going to hear Chad talk again about lighting. So hopefully with visual and what we did last in the fall and the visual software and a little bit of information from this chapter, you're on your own after that. Any comments, guys? Any questions there, my friend? Joe? Cool. That's all I have. Thank you.